Hello, everybody. Hello, Java User Group community here in Riyadh and all over the world. We welcome warmly our guest, Thomas. Hi, Thomas. How are you?
Hello, I'm good, thanks. I'm so happy to be here. Thanks for inviting me.
Thank you so much. Really, the whole community is very excited for this topic, and also by having you, they are very, very excited by having you also. Thank you so much for joining us.
Yeah, my pleasure.
Yeah, guys. So before we start, we give just a little bit introduction about Riyadh Java User Group. It's just a group, a jug, like all other groups. We are here organizing sessions, online sessions mainly, and also we are really deeply planning to have in-person sessions soon, very soon, inshallah. Uh, so we also advise you guys and recommend you to go to our previous sessions. It's in Riyadh Jag, YouTube. All our sessions are recorded. We've been like talking in this year a lot about AI. Also, we took some sessions in Quarkus. Sorry for that, Thomas. I know you're a Spring advocate, but no worries. So we will be shifting the focus from Quarkus into Spring AI. Spring is dominantly really amazing framework and having also the Spring AI embedded. So we will have, of course, fun and wonderful time with Thomas. A little bit about Thomas. Thomas is actually a worldwide speaker, a book author. He has really wonderful book, Cloud Native Spring Developer. Really highly, recommend you guys to have a look in his book and also follow him in Twitter and LinkedIn. So I won't talk much about the introduction. I know you guys are very excited, so I leave it with Thomas. Thomas, over to you. The stage is yours.
Thank you. So today I'm going to talk about how we can build AI applications using Java and Spring AI. You heard about me. I'm really passionate about anything Java and cloud native related. I wrote a book about this. I'm writing a new one with my friend Mauricio Salatino. It's called Developer Experience on Kubernetes. And I like contributing to different open source projects, including Spring AI. So I would like to clarify some terminology before moving forward with the practical part. When we talk about large language models and generative AI, we are in the domain of machine learning, which is a subset of artificial intelligence. And we have different roles in this scenario. We have data scientists. They're the ones that prepare the data that eventually are used by machine learning engineers to train a model. We can have different types of model. If we have a language model, then we train an algorithm to process natural language and produce natural language. When the model is trained, we go through the inference phase. That's when we actually use the model. It means we provide an input and we get back an output. All of this typically requires some dedicated infrastructure. So we might have also some platform engineers that provide all these capabilities and enable machine learning engineering teams. But how about application developers? Now, something that happened in the recent wave of AI is that we got a standardization of HTTP APIs in front of the model inference service, meaning that as developers, we can actually send an HTTP call to this API and consume machine learning capabilities without being experts in machine learning. So without having to interact directly with all the low-level details of a machine learning model. And that was really great because it means that now no matter what programming language we are using, or it could even be a terminal session. We can open a terminal window on our computer, send a curl request to an HTTP API, and consume machine learning capabilities. So we can use any kind of programming language, and Java is really great for doing this because we've been building this type of integration with other systems for decades using Java. So it's really a great language to build what we call AI-infused application. So it's an application that integrates with a model. All right. Spring AI is what enables our Spring Boot application to integrate with these large language models to consume generative AI services directly from our Spring Boot application. And we can use Spring AI not only to interact with these models, but we can also integrate our own data and our own APIs with these generative AI models to achieve even more powerful workflows. And today we'll see a few of them. But first, we need to solve the problem of the generative AI model. So we need some kind of inference service. We need some models we can use in our applications. And there are many, many different options on premises, online, in the cloud, enterprise, open source. What I want to show today, and I'm going to use today, is called Ollama. Ollama is an open source tool that you can run locally on your computer. It works similar to Docker. So just like Docker, we can use it to manage and run containers. We can use Ollama to manage and run large language models. And we can do it directly on our local machine. So we don't have to establish any subscription or even be worried about sharing sensitive data with the cloud provider. It's a really great way to get started quickly because everything runs on our machine. As I said, an inference service provides an HTTP API we can call. So for example, with Ollama, we'll get this inference service running locally over HTTP. So we can send a curl command and interact with the inference service and ultimately consume capabilities from a certain large language model. Now, we're not going to use this, of course. We want to integrate it directly into our application. But I want to show you Ollama that I have already installed on my machine. Ollama also comes with a nice UI if you want to have a nice chatbot always available on your local machine. But what is interesting for us now is that I have an Ollama service running. I have a series of large language models that are available for me to use locally. And I can pull and download new models. I can run them. So the user experience feels very similar to Docker. But in the example today, we'll use Ollama directly from our Spring Boot application. So let's talk a bit more about this application. I have a standard Spring Boot application. On top of that, I add Spring AI. That's what we need to integrate the application with an AI model. I'm also using Vaadin to get a nice graphical user interface implemented in Java directly. So we'll have a bit nicer demos than just looking at the terminal screen. And also, I'm adding a library that I built. It's called Arconia, and I'll show you in a minute what it does. It's aimed at improving the developer experience and observability capabilities of a Spring Boot application. I'm going to integrate with a database, in particular PostgreSQL. So that's a very standard for a Java application to interact with a database. I also want observability, so I'm going to export telemetry to an observability platform based on OpenTelemetry. This is usually very important whenever we want to run an application in production, but when we start infusing our application with Gen AI capabilities, we really need observability already during development because there are so many things happening under the hood. And without a good observability solution that is available already at the early stages of our software development process, it's going to be quite hard to evaluate and tune the models for our own use cases. Finally, of course, I need to integrate with an inference service. So I mentioned that I'm going to use Ollama, but you can also use any other provider. Just like Spring Data offers a nice API and abstractions to interact with any kind of database, Spring AI offers the same. So you can easily switch between AI inference services without having to change your code. You just swap a dependency, just like you would do with a database when using Spring Data. All right. Now, I have my application up and running, and I need these three integrations. I would really like to go directly and start implement my business logic. So I don't want to spend too much time setting up these three services I have to integrate my application with. And that's where Arconia comes handy, because one of the features offered by Arconia is called Arconia Dev Services. And as you can see here, I included in my project three dependencies called Arconia Dev Services, one for Ollama, one for Grafana LGTM. That's the observability platform provided by Grafana based on OpenTelemetry, and then one for Postgres. So by adding these dependencies in my project, whenever I start my application, either with Gradle or with Maven, I get all these services started for me, running as containers. So I don't have to provide any extra configuration or boilerplate myself. I just run my application and I get everything I need to make it work. I also added OpenTelemetry Spring Boot Starter. That's in order to get observability out of the box. So again, I don't want to spend too much time configuring things. So I really like having a quick startup here. Nice developer experience. I get all these things out of the box. I can also run it with the Arconia CLI that I built, but we're going to rely today on Gradle, but it works the same in Maven. So I have my project. Let's open it here. And the entry point to Spring AI is called a chat client. Now, I want to interact with the chat model. And just like I interact with the REST API using a REST client, or with a database using a JDBC client, Spring AI offers a chat client. So the first thing I want to do is build a chat client instance. Now, just like all the other type of clients that Spring provides, we don't auto-wire a client directly, but we auto-wire a builder. So Spring Boot provides auto configuration for a builder that you can use to build as many chat clients as you want. So here for now, I'm just gonna build one with the default configuration. And now we can use our chat client. So I'm gonna define a get endpoint so we can test it out like this. We're gonna chat, and then I want to call the chat client. I'm gonna specify some input, some query that comes from the user. So I'll pass it here in the prompt. And then I'm gonna call the model and finally return the response. So I built a chat client. I'm defining a prompt. In this case, the prompt comes from the user directly. I call the model and I get back the result. So let's give it a try. I can call the application on port 8080/API, and I need to provide a query. So let's ask, what is Java? Tell me in one sentence. And let's see. Oh, yes. I need to specify this. So we have a request param here, query. All right. We're using a get request. And there it is. And I got the answer back. Now, this is very basic interaction. Chat client, I'm sending a prompt, I'm getting back the result. But typically, we don't want to expose the full prompt responsibility to the user. So what if I want to ask questions about a specific programming language? Instead of having the full prompt coming from the user, I can parameterize it. What does it mean? I can define what is called a user template, where I can specify something like this. So tell me what is, and then we have the certain programming language in one sentence. And now, instead of getting the query, we're going to get the language from the user. So we are controlling the prompt design for our application, and we only ask the user to provide the language. Now, this is just a string, but in a typical application, I would probably show this as maybe an enumeration in a dropdown so that the user can choose what language they want to learn about. Now, this template needs to be parsed correctly. So I have my simple text in here, but I also need to specify the argument. So we have a parameter called language that needs to be filled out. So now dynamically, every time I call this endpoint, the language is inserted in the prompt for me. This is what we call a prompt template. So we can make some more advanced prompts where only certain parts are coming from the user. Let's see if it works. So we call the parameter language now. So I can say Java, and there it is. So now I can say, for example, Golang, and I get a response from Go as well. And as I said, this is all running locally. It's running with Ollama. And I can show you because, as I mentioned earlier, whenever I run the application, I get all the different services up and running for me, including an observability platform. So I actually have a Grafana platform here where I can inspect all the operations that are going on under the hood. So let's see, I called the API earlier. I can get all the details of the operation I ran. Let me zoom in a bit. So it's bigger. So I can see that I'm sending a GET request to the /API endpoint on my application. This is the normal Spring Boot application. I get information about the endpoint. Perfect. Internally, we are calling a Spring AI chat client. We can get more information about the chat client. We can see that in the end is calling a model called Granite 4 3B. This is one of the models I'm running locally. It's an open source model from IBM. And we can see also information about the model. So I can see, for example, the tokens that I'm using. Now, this is not maybe particularly relevant right now because I'm running locally, but if I'm using a cloud service, then tokens are really important because based on the number of tokens, I'm gonna have to pay a bill based on that. As you can see, we don't have information about the prompt content. So I'm not exposing any sensitive data here. This is really, really useful because it's coming out of the box, ready to be run in production. All this instrumentation is part of Spring AI project. And by default, we don't expose any sensitive information. That makes sense. However, when I'm in this phase, during development on my local machine, I would probably like to see more information about what's happening under the hood. So I want to enable now a better visibility of that information, including the prompts, like my request and the response from the model, something I wouldn't do in production. Now, I can do it directly here in Grafana, but there are also some specialized observability platforms just for AI. So I have integrated one of them also through Arconia. So let me enable that because it will allow us to get even better insights in what is going on under the hood. So I have added an extra dev service called Phoenix. Phoenix is an AI observability platform. It's also an open source platform. And I need to enable it in the properties now. So I'm gonna turn off Grafana and enable Phoenix. I'm also gonna shut down logs and metrics because I'm gonna work only with traces for now and enable instrumentation for Phoenix. All right. I probably need to restart the application. Let me do that. Perfect. So what's happening is that Spring AI comes out of the box with all the instrumentation for every chat interaction. So I show you in Grafana all the things you get out of the box. Now what I'm going to do is adopting a more specialized platform for the sake of this demo, because it lets me show you better what's happening under the hood. But this is also something that could be useful in your own project in order to tune your application and do some evaluation of different models and different prompts, so you can find the best fit for your own use case. And in here, I'm going to get now information of the URL where Phoenix is running. There it is. Perfect. So I have my application. Let's try sending a request first. What is Golang? Perfect. And now, yeah, we can switch to last 15 minutes. Now we can see information, again, same type of information. We can see we're calling a chat client, but now we can see more insights about what's happening under the hood. My input was tell me what is Golang in one sentence. And this was generated dynamically by Spring AI because I had a template where Golang comes from the user and the rest is defined by the application. And then I can see information about the model. So I can see I'm using Ollama with Granite 4. I can see the output from the model, and I can also get information about the tokens here. So I can see all the number of tokens I consumed and the total cost. Now I'm running locally, so the cost is 0. But if I was using some cloud service, a paid cloud service, then I could also see how much I'm spending for each of these interactions. So I'm going to use this tool for the rest of the presentation just because it focuses more on the AI part. But of course, Grafana includes everything. So it's not just AI specific, but it's probably what you might want to use in production because it includes all different types of information from your application, not just AI. All right, now back to the application. Here, we saw some basic interactions with the model, but so far we are still working with text because large language models, they work with unstructured text. As you can see, we are always returning a string. But that's unlikely what we need in our application, where we typically work with structured objects like Java classes or records. So let me define a record. I'll call it language with a name, with a description, and with a type. And now, instead of returning a free text from the model, I want to enforce it to be of type language, because then I can really use it programmatically in my application. So instead of returning a string, I return a language. Now, the model by itself still only produces text. So all the functionality for instructing the model to return something that can be parsed into a language object, that's something that Spring AI is doing under the hood. All right. Let's see. Let's ask what is Java. Now we are getting back a structured object. So we can see we have name, type, and description. But how did we obtain this result? That's why I brought this in. We have the latest chain here. Okay, let's see what type of information we send. As a user, I just specified, tell me what is Java in one sentence, right? That was my prompt. But under the hood, Spring AI has augmented the prompt with formatting instructions. We can see it here. All these parts I didn't write it myself. Your response should be in JSON format. It should be following this JSON schema. And there is a JSON schema definition of my Java record. So all this thing is taken care of by Spring AI. So all I need to do is specify the type of Java object I want to deal with, and Spring AI makes sure that the model returns information that adhere to that type of record or class. So dot entity, I can specify Java object, and I get back a structured object. If I do dot content, I get back the unstructured text that I receive from the model. All right. I'd like to show you one last thing. So let me go back to string and content. So we saw how to get back something that is not a string, so how to work with structured data, but the input is still text. Actually, many models, though, can support multiple types of content, not just text. For example, they support images. So what we can do here is going back to pass a query. We get the query from the user, but on top of that, I want to add some images. So I have an image in PNG format, media type util PNG. Yes, and I need to specify an image. So I have an image in here, is a PNG image. We can see it represents a cat. So now I can inject that in here. I'll define it as a resource. A resource is a Spring framework abstraction to deal with any kind of object. In this case, I want it to be an image. And the name is cat png, like that. Perfect. So now I'm reading from the class path the image, and I can pass the image in here. And I'm getting the wrong import there. Let's fix it. Value of image png. We'll do it manually. So what I'm doing is providing not only text, but also some media content. It could be images, but it could also be audio, it could be video. It depends on the model, whether they support this or not. Now, the model that I was using up to this point actually doesn't support images. And that makes it possible for me to show you how to customize a certain call with different parameters. So I can provide some chat options like this. I can provide different types of parameters, but the one we are interested in updating is the model name. So if we go back and check my local models in Ollama, there is one that supports dealing with images, this one. So I'll copy the name. There it is. I can also change the temperature. This is a degree of how much creativity I want the model to put in the answer. So maybe I want high degree of creativity, so I put the temperature to 1. All right. Now, if that was correct, I can provide a query like this, saying what's in the picture. And now the model should be able to understand the picture and tell me what's in it. Let's see. There it is. There's a cat with yellow eyes looking directly at the viewer. And that seems pretty accurate. There is the picture of the cat. And for this case, I've used a different model. So I can easily change the model based on the specific functionality. I can show you also from Ollama that I have 2 models loaded. One of them is the vision model. Ollama lets you run models on the GPU, but if you don't have a GPU on your machine, you can also run them on CPU. They're a bit slower, but they can still run on that. So that's also pretty nice to get started with this. All right. Now we covered the basics. Now I want to start showing you something a bit more advanced, because up to this point, what we did was first establishing a single interaction with the model, where we simply propagate the prompt from the user to the model. We saw how to template it a bit. So we started uh, consolidating the prompt structure, the prompt design inside the application, and then we build on top of that to support even multiple types of content. So that's what we call multimodality. And Spring AI takes care of all of this under the hood. So if we need to tell the model how to structure, how to format the output, Spring AI does that for us, as I show you in the observability platform. We can exchange audio, images, text, video based on the type of model, whether it supports all these formats or not. And then Spring AI also takes care of converting the output based on what we need. So the functionality under the hood works exactly the same as Spring Web. In Spring Web, whenever I send an HTTP request, I get back a JSON object. That's because under the hood, Spring is using a library called JSON to parse between JSON and Java objects. And this works exactly the same way. There's an exchange and a conversion between JSON and Java objects. And Spring AI does all of that under the hood for us. Now, we have a big problem to solve. So this is the UI of the application that I mentioned earlier, built with Vaadin. What if I say something like this? Hi, my name is Thomas. All right. Now, if I ask, what's my name? I get this answer. As an AI, I don't have access to personal data. So what happened here is that large language models, they don't have memory. They are a mathematical function. We pass some input and we get back output. So there is no state involved. Nothing is stored on the model. So as an application developer or as a user, it's up to me to provide the whole conversation. So if I start this again, like this, and I say, hi, my name is Thomas. If I want to ask what's my name, then I would have to provide the previous conversation myself. So I would have to do something like this, and I pass all this information. And then now the model know what we talked about earlier and can tell me, okay, your name was Thomas. Now, of course, I don't want to do this as a user myself, but the application can take care of it out of the box. So let's do that. I'm gonna move to this service. So we have our chat client that we built earlier, but now we start customizing because so far I've been using the default configuration. So the first thing I want to do here is defining what is called an advisor. And an advisor is an interceptor. So if you ever used Spring Web, we have this concept of an interceptor, also with Spring Security, that can intercept an HTTP request and perform some operation, maybe checking for authentication, for authorization, setting up some HTTP headers, or maybe prompting you to authenticate if you're not authenticated yet. Advisors work in a similar way. So before we call the model, we want to intercept the prompt and do some operation, do some other activities that can help us achieve the final goal. In this case, the goal is being able to interact with the model in a conversational way. So making sure that the model knows about the previous conversation. And Spring AI provides out of the box an advisor for doing that. It's called a message chat memory advisor, like this. And in order to build an instance, I need some kind of storage for the memory. There are different possibilities in Spring AI. You can store it in Redis, in MongoDB. You can store it in PostgreSQL. In this case, for simplicity, I'm using the default chat memory implementation, which is in memory, like this. So now that I passed the chat memory advisor, every time I call the model, Spring AI makes sure to retrieve the conversation and include it in the prompt for me. And in order to do that, Spring AI needs to know what conversation we want to restore, because there can be multiple conversations in an application. Different users can have different conversations. So I also need to provide a conversation ID. Now, for this example, I'm just generating a random ID. But in a real application, you would use something, maybe a user ID. If your user is already authenticated, then you can use the same user ID or session ID as a conversation ID as well. But now that I've done this, let's see if the application is working as it should. So I'll try again. Hi, my name is Thomas. And if I ask what's my name, and now it knows my name. So what happened under the hood is the exact same thing that I've done explicitly earlier. So Spring AI retrieves the conversation history and add it into the prompt for me. So I can also visualize it in here. Now I'm not calling the model directly, but first there is this step, message chat memory, that makes sure that all the memory is included in the call. So I can see that in this case, the whole conversation is sent to the model. I have the previous two messages, hi, my name is Thomas, and hello, Thomas. And then my second question, what's my name? So the model has access to the entire conversation, and then it knows how to answer. And this is provided as an advisor. So we can see we have this interceptor step between the chat client and the call to the model. Let's try to visualize it. So whenever we send a question to the model, we want to augment the prompt with the memory. So Spring AI does this out of the box using the advisor. It reads the memory. But then it also, of course, makes sure to write and update the memory every time we get a response. So it's doing both of these steps. When we ask a question, it retrieves the memory. And before sending the response back to the user, it makes sure to update the conversation memory. So we get all the latest messages in it as well. Now, having established that, we need to solve one more problem. I've been asking so far questions about Java, about Go. That's something that the model has been trained on. So I mentioned earlier the phase of model training. The model that I'm using has been trained on a lot of different types of information, including programming languages. But what if I ask something recent? Like I mentioned, the Arconia Dev Services functionality, it's something I built recently, just a few months ago. Probably the model doesn't know about that. Let me check. So when the model doesn't have that information as part of the training dataset, two things can happen. The best scenario is the model tells you, hey, I'm just an AI, I don't have access to all the information, so I cannot answer. And the worst scenario is what happened right here, where the model hallucinates, or in other words, it makes up an answer. So here it's just making stuff up. This is completely untrue, but also the model doesn't know about this. So there's no way the model can answer this question correctly. So what I have to do in this case is providing some contextual information to the model. So I have this blog post where I explain what are coordinated service. So I might do some Google search, extract relevant information, and add it in here. So I can say, consider this context, and I paste all that information. And then I say, based on the context, tell me what are Arconia dev services. And now it's hopefully answering correctly because it has that additional contextual information. You might have spotted a pattern here. This is the exact same thing I had to do earlier with the memory, where it was me as a user that had to enhance, augment the prompt with the past conversation. Here is the similar approach. I'm enhancing the prompt with some contextual information about data the model wasn't trained on. And you can imagine the solution is kind of similar because instead of providing the context as a user, this is what is called prompt stuffing. So we stuff the prompt, we augment it with all this additional context information. I want to delegate the application to do that. That's the pattern called Retrieval-Augmented Generation. So we want the application to augment the prompt with additional context that comes from some kind of data source so that the model has all the necessary information to answer correctly. Otherwise, as I said, either it won't answer or it would answer by making stuff up. So where do we get this context from, though? In the previous example, perhaps a Google search would be enough because I'm searching online for some blog post about this topic, and then I can include that. So let's try and explore this option by getting the context from a search engine. There are many search engines out there that expose an HTTP API that can be used by applications like this. So it's APIs designed to be used as part of an AI-powered system. In this case, I'm using an API or a service called Tabili. So let's see how I can do this automatically. And I'll do that with, there it is, and I'll do it with another advisor. Now, I'll remove this. We won't work with memory for a while. Instead, I want to add a retrieval augmentation advisor, like this, builder build. Now, this advisor is responsible for performing retrieval augmentation operations, which means first, retrieving context from some data source, and second, adding all the context information into the prompt. In order to do that, I need to specify what is called a document retriever. That's an API that we can use in Spring AI in order to retrieve context or documents from different sources. Since I want to interact with the search engine, I built a custom implementation for that. And since it's based on a HTTP API, I'm going to use a standard REST client from Spring, REST client builder, like this. Perfect. Now, if we have a look at this retriever, what is going on under the hood is that given a query, it performs a post request on the Tabili search API and retrieving all the results from the search. And then after that, my advisor will include all that information into the prompt. So let's see if it works. And just for the record, I defining here the URL for the Tabili API and using an API key. So I have created an API key with my personal account on Tabili because it's not freely accessible. So I created this API key, and I'm calling that search engine now under the hood. So you can see I'm not changing much in my code. I just add this retrieval augmentation advisor. So back to here, what if I ask now what are Arconia dev services? Let's see. So it's taking a while. So that's because we are intercepting the request and we are sending an extra request to the search engine. Okay, so now I can see that I'm getting also a pretty accurate answer. But I want to prove that what's happening under the hood is exactly what I'm saying. So here, so when we call the model, we can see that the prompt is augmented. Again, I haven't modified this. This comes from Spring AI. So I have context information is below, and I have here a series of results from the search that we've done on Tabuli. So we can see all this information is contextual information. And at the end, the important part, given this context, answer the question, what are Arconia dev services? And then the model answer. So this pattern is really powerful. We are intercepting a request and we can do a lot of different things. We've seen how to deal with memory. We've seen how to deal with retrieving information from a search engine, but we can also retrieve information from our own data. Now, if we do that, we need to establish what is called a vector store. A vector store is a database where we store our own data in a special format that we call embedding. And embeddings are numerical vectors. If we do that, we can perform what is called a semantic search, meaning we can search by the meaning of our data and not by keyword. Typically, we search by keyword. So in a text, if we want to search for the word Java, then we search for the exact match of the word Java. Semantic search is something different. It allows you to search to get back data about Java, even if your question is about programming language, because Java is a programming language. So semantically speaking, they are related. That's how this works. But an example should clarify things because we have to interact with a different type of model this time. It's called an embedding model. Let's see how it works. I can define a new endpoint in here. Let's say embed like this. And as I said, an embedding is an array of floating point numbers. So I'm gonna pass a query. And we need now not a chat client, but we need what is called an embedding model. That's another API from Spring AI. So this one, I can auto-wire it directly like this. All right. Now, given some text, I can generate the embedding representation like this. So if I go back to my terminal, we can try that out. So if our query is, oh, I probably missed the annotation again. Let me do that. Like this, query. Okay. So you might have noticed I'm never reloading the application myself. That's because I'm using something called Spring Boot DevTools. I can show you in the dependency. So I have Spring Boot DevTools. So whenever I make a change in my code, it reloads the application automatically. That's really great because it means I can focus on my code and I don't have to continuously stop and rerun my application. And all these dev services, they work together with DevTools. So whenever I'm restarting automatically the app because I make changes, I'm not also restarting all the services. That would take too much time. So it's only the code that is reloaded, which is very convenient. Anyway, we were talking about embeddings. Let's see Java. All right, so this is an embedding representation of the word Java. So this array of floating point numbers mean Java. That's how a model would understand this. And this is the key of Retrieval-Augmented Generation based on our data, because what we do there is establishing an ingestion pipeline. So we get all our data from whatever source. It could be data we already have in the database. It could be data we get as input from the users. It could be PDF documents. It could be wiki pages. It could be text documents. It could be pictures. We transform it so that all this data is better suitable for this use case. For example, if you have a long document, I might want to break it down into smaller pieces. And finally, I write it into this vector store. In my case, my application was already using Postgres, so Postgres can also support storing vectors. And I've done this already. I've actually stored as embeddings two little stories. They are markdown files, and they are currently stored in my PostgreSQL database as embeddings. So what I can do now is hooking that up into my Retrieval-Augmented Generation solution. Let me save that for later here. Okay, so I'll keep my Retrieval Augmentation Advisor, but now I'm changing where I'm retrieving the data from. So in this case, I want to return them from a vector store. So I'm going to use a vector. Let me disable this. Vector store document retriever, like this. So earlier, we interacted with the search engine, and that was using a REST client because it was an HTTP call. In this case, we are interacting with the vector store. So I can use the vector store API from Spring AI like this. So let me specify the vector store. Perfect. So again, this is an advisor. It intercepts the request. It performs a search on my database, return all data that is relevant to answer my question, and then add it to the prompt. All right. Where is the application? Here. So the story, one of the stories is about a character called Yorek. So I could ask, what is Yorek's dream? And now I can see that Yorek dreamed of going on an adventure around the North Pole and seeing the Northern Lights. And that's actually correct. So let's double check what happened under the hood. So now we can see that we are not calling a REST endpoint for a search engine, but instead we are relying on this embedding support in order to generate an embedding text for our question. And then what happens is that the vector search works in a way that you can imagine all these vectors as numerical vectors. They are arrays, all these vectors in a multidimensional space, and they are at different places in this space. Now, the intuition is that the closer they are to each other in this multidimensional space, the closer they are in meaning. So when we perform a semantic search, we are getting the vector for our question, what is your extreme? And we are comparing it with all the vectors that are in that space. And we are only getting back the ones that are the closest to our original question. That's how similarity search works. It's by checking the distance between all these vectors. And that's how we retrieve all the contextual information from our database. And that's how it ends up also in the prompt. So this is the augmented prompt. Again, with this context information is below. All of that comes from the database. And finally, given the context, answer the question. All right. Now, there's one more problem I would like to solve. So we have this set up right now, Retrieval-Augmented Generation. We can augment the prompt with some context. We can retrieve the context from different sources. But this is very specific to the type of source. So we have one implementation for vector stores. I created my own implementation to interact with the search engine, but that doesn't scale much. And in particular, it doesn't let me dynamically choose which route I want to go to. Because if you check the code I have now in my class here, so this chat client, now it will always answer question based on the data in my vector store. So if I ask a different types of question, let's try. If I ask, what is Java? It will not answer because Java is not part of that story. So I need a more dynamic way in order to support different use cases so that the model can decide when to call a search engine, when to call a vector store, and when to do something else. So we need to introduce the concept of tools. Now, tools are basically APIs. In our application, we have tons of different APIs. In Java, we have Java methods that gives us access to different types of functionality. So instead of specifically talking about retrieving data, we could just talk about APIs, and we call them tools. We call them tools because we inform the model that we have a list of available tools. So we could tell the model, hey, we have available a way to perform a web search request. We have a tool to retrieve data about the story where Yorick is the main character. So we can establish different tools, and then the model itself decides if and when to call them. So the first request, the model figures out, okay, I can see that all these tools are available. If there's one that seems that makes sense in that context, it will ask the application, please execute this tool for me. And that's where Spring AI will accept the request from the model and call the API for us. So we're talking about Java, so this is just a method call. So what happens is that the model says, please call this Java method, and Spring AI makes sure that we call the Java method and return the result of the Java method call to the model. Finally, the model can answer. Now, this is much better visible with an example. So let's start with a simple example. I have here a class. It's called my tools. This is a Spring component, and just standard Spring Bean. What I'm going to do now is defining a method called get current date, and this one will return the current date. Instant now to string, like this. Now, I can turn any Java method into a tool by using the tool annotation. As a minimum, I should define a description so that the model knows when to call this method. So this one is retrieve the current date as UTC timestamp, for example. So I can mark certain parts of my application as tools, and then I can inform the model that these tools are available for calling. So I can now get these Spring components and add it here. My tools. Once again, I'll get rid of that. And instead, I'm going to specify here, not that one. I'm going to specify some tools, some default tools. So I'm passing my Java Bean that includes all the tools. In this case, I only have one tool. And now I can ask questions that involve that tool. So for example, I could ask the model, what time is it? That's not information that the model usually have because it doesn't have access. But now it knows that there's a tool available for that. So it tells me immediately, hey, the current dated time is blah, blah, blah. And this is the current time in UTC. Now, what happened under the hood, let's see here, is that we sent two requests. The first request, we ask, what time is it? And we also told the model all the tools that are available in our application. In this case, we only have one tool. So you can see what Spring AI does under the hood. It provides this JSON schema for the tool call. So this is exactly the same functionality we saw earlier for structured output, but in this case, is the JSON schema representation of how to call a certain Java method. So we can see that in this case, we have no properties required because the method doesn't accept any argument. So it's a simple one. We can see the information, retrieve the current date as UTC timestamp, and the model returned with the request for a tool call. So it actually asked the application, hey, can you call this method for me? That's what Spring AI does. So we can see a tool call after it where we have no input because the method doesn't accept any argument. We get an output. We can see also some metadata. And then this information, the result of the method is included in the prompt. So we call the model again, but this time we provide the method result. So we can see the full conversation here. We ask what time is it. The model says, please run this method for me. We do that. Transparently for us, it's actually Spring AI doing that. The result of the method is sent back to the model, and the model finally answers what is the current date and time. This is how tools work, and we can use tools for any kind of functionality. Now, you might have wondered why I saved these previous bits of code. We had two examples earlier, one where I did this retrieval augmentation advisor flow based on a vector store, and another one where I used the search engine. Now, as I showed earlier, whenever we have this type of chat clients, they only do one thing. And that's typically not enough. I would like to dynamically choose different sources for information or different tools to call. And actually, tools are the solution to this because I can turn all of that into tools. So I have here a tools class where I defined those exact same methods where I have a chat client, where I have a retrieval augmentation advisor as a tool. So now I have multiple tools for different types of information. One that retrieves data from a vector store with certain metadata, so only about stories that take place in the North Pole. One also from vector store with some other metadata. And then I have a third tool to retrieve information from a search engine. So now the model can actually dynamically choose which route to take. So let me update this. Like this. All right. So what happens is that we are establishing an agent. So we have a chat client, the primary chat client that will act as an agent. And then this chat client can dynamically choose what to call based on the question, based on the query. So it might be tool number one, it might be tool number two. But if none of the tools make sense, then the agent can simply decide, okay, I'll use the data I was trained on to answer. And finally, we get back the response. So let's have a look at this final example. So now I can ask, what is your dream? And I expect my agent, my chat client that acts as an agent, to go and choose the right tool. Perfect, is correct. Now I can ask, what are Arconia dev services? And I expect now the agent to route my request towards the tool that performs a web search request. It's taking longer because it's performing this call. Let's see. Almost there. Come on. Yeah, there it is. Oh, it was producing a really long answer. Yeah, some made up information, but still is based on information coming from the web search results. All right. So that was my last example. So just to mention it one more time, what I'm doing here is having one chat client, this one, that becomes an agent where I provide multiple tools, and those tools are providing different types of functionality. Now, in this case, I have functionality to perform a web search engine request, to perform retrieval from a vector store, but you can have any kind of method here. And you can even have external APIs call using something called MCP. So instead of having your own APIs in your code, you can use an MCP server. MCP is short for Model Context Protocol. It's a standard way to consume tools over the wire. And actually, in my case, since I was using the Tabili search engine, I don't need to implement my own code. So if I go back here, I have my search engine document retriever. So I could actually get rid of all of this and just use the official MCP server provided by Tabili. And Spring AI also supports that. I actually have it defined it here. So I have an MCP client where I can use the Tabili MCP server provided by Tabili itself. So I don't have to implement my own code to interact with the search, but using MCP, which is supported in Spring AI natively, I can actually consume these tools, even though I haven't implemented them myself or are not available in Java. So that's really a great point about that. But that was my last example. So thank you very much for joining this session. I have lots of source code available on GitHub. A couple of links is there, but I'm going to share all the links afterwards, including the slides. And if we have some time, I'd be happy to answer your questions. So thank you.
Yes, thank you so much, Thomas. I think we have a couple of questions. Can you hear me, Thomas?
Yes, yeah, I was reading also. So the codes I can see it's on GitHub. So if I click on this link, so it's all on GitHub. So it can run locally because I'm using Ollama. The only thing that requires an API key is the search, but it's all documented in the README file. But feel free to open an issue in the repository if you have more questions. I also have this separate repository that is also linked here, where I have more extensive examples about different features in Spring AI.
Awesome. Thank you so much. Yeah, if you would mind, please share us also this the presentation. That will be great.
Yes.
If you don't mind. Yeah, sure. So we have a couple of questions, if you don't mind. Like there is one question regarding the performance of the chat memory. So if we keep adding the chat memory, do you think how well performant it will be like in a couple of hours ago?
Yeah, so that's definitely something to consider. So the default implementation available in Spring AI that we used earlier, let's see, I think I have it in the chat controller. Not anymore, but anyway, let's go chat memory. Yes, so the chat memory abstraction is quite generic. So it lets you add and retrieve conversation. Now, of course, here it's important to distinguish between two concepts that sometimes are confused together. One is chat memory and the other one is chat history. Now, chat history is something that is about storing the entire conversation. So we might need it for different reasons, maybe because of auditing, or we might simply want to save the entire conversation. And that's something we wouldn't use in this case. Like chat memory is more about providing all the relevant context in the conversation. So we need to be careful about how much information we want to expose. We don't want to include a history from 2 hours of a conversation, but we want to select the information that we need. Now, there are a few implementations available in Spring AI. The one that is used by default is called Message Window Chat Memory. Now, this one, it keeps only the 20 last messages. So whenever there are more messages, the oldest ones are trimmed. Now, this is not necessarily good in all situations because you might miss out on important information from previous conversation. So you can provide different implementations. You can provide an implementation that considers tokens instead of messages, or also one that provides a summary. So whenever we are about to exceed a certain limit, we use a chat model to summarize the past conversation and then include that in the next call. So that was a very relevant question and something really important to consider. And the type of strategy to adopt, it really depends on the use case. But it's definitely something to consider because it will have performance impact. So we don't want to just add the entire conversation, but only what is relevant based on different strategies that, and which one to pick depend on the on the situation. I hope that answered the question.
Yeah, that's really very good.
Yeah, so there's another one, how the agent can dispatch the request to the good tool. Okay, now this one is really up to the model. So we are relying on the large language model to be able to act as a decision engine. So, and to make a good decision, the model needs enough information to know what tool is useful for what purpose. So if we go and check what we did earlier here, when I send my request about what are cognitive services, all the tools have to, well, they don't have to, but we need to have some description associated with it. Now, the more precise the description, the better chance we have for a model to pick the right tool. Because if I'm not detailed enough in the description, then the model doesn't know when to know the tool. So this is something that we need to tailor. So we need not only pay attention to the tool there, where is it? Tool class. So you can see the annotation. This is one of the parameters we want to tweak to get better results. So we can try with the description. If we see that the model doesn't pick this up, even though we want to perform a web search request, then it's probably the description that is not good enough. But sometimes even a good description is not enough. That's why we have the possibility to specify additional information on each parameter here. For example, here I could say the search engine keywords or something like that, description. So there are all these steps that I can take in order to maximize the chance that the model makes a good decision. But it's really up to us as developers to make sure that we have the most meaningful, concise, and precise information in here, both on the tool, but sometimes it's also necessary to do the same for each parameter. Yes. Let's see. I can see questions about what is Spring and Babel. So Spring and Babel is a great project that was created by one of the founder of Spring, and it's actually based on Spring AI. So it's built on top of some of the core APIs of Spring AI. And I can recommend checking out the official website and repository. There are tons of examples, both in Java and Kotlin, and addressing all these different use cases. I don't have examples ready here to show, unfortunately. But on the GitHub project, there's really tons of useful examples showcasing all the powerful features that the framework offers. And yeah, it's built on top of Spring and Spring AI. So for embeddings, yeah, last question. So I mentioned embeddings earlier. I'm using PostgreSQL as a database, and in order to have Postgres supporting storing these embeddings, what I'm doing is using an extension to Postgres called, I'll show you here, called pgvector. So actually, the local service that I'm running for Postgres is using this pgvector image. So this is a PostgreSQL image with the extension called pgvector that let me store embeddings. And I'm not sure if that was the answer to the question, but you can definitely persist them in the database and even store them side by side. So if you're using Spring Data, maybe you're storing different types of data in a normal SQL table, you can actually have an additional column in your table where you store the corresponding embedding format. So that's very useful because it gives you the possibility to continue doing normal searches, but also doing a vector search. And if you're interested in that, I recommend checking out the latest Spring Data version that ships with Spring Boot 4, because in Spring Data, it's now also possible to use Spring Data repositories to perform vector search in a few different projects, including JPA, and that works with Postgres too. Yes. Is there any more question?
Yeah, I have a question, Mr. Thomas, if you don't mind.
Yeah, of course.
Yeah, so I think we don't have questions here in the chat, but I just now I have a question in my mind. Like how mature is now Spring AI, and like do you have in mind some predictions using Spring AI in productions?
Yes, so Spring AI got GA last May. So with version 1.0.0 that was released in May, the framework itself is production ready. And I should mention that the Spring AI 1 release train that works with Spring Boot 3. Tomorrow, Spring Boot 4 will be released. Spring AI is planning to support Spring Boot 4 in an upcoming release, Spring AI 2. So if you want to use Spring AI with Spring Boot 4, there's a bit of waiting. to do. But Spring AI itself is production ready. It's including all different features that we need in a production environment, such as observability. That was a big thing, as I mentioned earlier, because we really need to have that kind of visibility into AI. But the production consideration here is a bit different, because generally with a framework or a library, if that is production ready, then we can use it in a production application. But in this case, the part that is the most fragile, I would say, is the large language model itself, or the whole concept of generative AI, because large language models are not deterministic, and we typically work with deterministic systems. So there's lots of work that needs to be put into our application in order to constrain and kind of wrap the model into as much determinism as possible, knowing though that we are integrating with something that is not deterministic at all. So I think that's the part that probably is important to consider about whether something is production ready or not. Spring AI offers lots of things towards that direction, but I would say that it's not enough. There are other things that we would need to include in a production ready system. For example, the whole concept of evaluation and testing. This tool I mentioned, this one, Phoenix, is one of the many tools out there to perform evaluation, meaning we need some kind of quality assurance of our solution. And how do we do that? Because it's not deterministic. So all these tools provide some way to evaluate the data. So in here, I can annotate and specify if something is if something is relevant, if something is correct, or if it's made up, and build some data sets where I can really test my application in order to ensure that it's production ready. So I would say that without all these extra components outside the application, it's a bit hard to say if something is production ready or not. So I think Spring AI is an important piece of the puzzle, but I would say it's not enough to say whether an application is production ready or not, because it depends on how we are evaluating the model integration and the quality around how data is processed and produced by these large language models. So probably that was a long way of saying it depends, but I hope that was useful.
Yeah, that's really useful. Yes, it's not about Spring AI. The whole the whole ecosystem should be also ready to support the Spring AI. And yes, truly yes. There's a question from Ahmed. What are the best open source coding agents? From your experience?
Yes. So there are many. Like one of the ones that I like using is called Continue. You can check on continue.dev. They provide a plugin both for Visual Studio Code and for IntelliJ. And a great thing about Continue is that, it provides lots of coding agents functionality inside your IDE. But the great thing is that you can plug in your own favorite model, both cloud models, but also local models. So I use Continue a lot with my Ollama models running locally, but I also use it sometimes with Mistral AI in the cloud, and it's very easy to configure. It also has a very structured way of providing information to the model. So they have the concept of rules that you can add to your repository so that you can share the same kind of settings for using a model with all your colleagues in the project. The rules are categorized based on different parameters, but then you can obtain support from a large language model respecting your own guidelines in terms of how to write tests, how to code, what kind of conventions to use for the code, all those kind of things that sometimes are hard with large language models because they can output various different things. But by including those rules, those prompt instructions directly in the source code, we have a way to get a more controlled output, even across developers in the same team. But this is one of many. So there are many out there, but it's one of the tools that I use the most, at least.
Yes, thank you so much, Thomas. I think we should have more questions. So at the end, I really thank you so much, Thomas. And I would like also to thank all the audience and the community. It was really great presentation, amazing examples, very good exposure on Spring AI. I would leave the final words for you, Thomas, if you'd like to say something.
Yeah, I'd like to say thank you very much for inviting me, and thank you all for joining. It was really great for me. So have a great day.
Thank you so much, guys. Bye-bye.
Bye.